If you know about me, you know that I work on historical video games, and especially right now I'm working on one that is set in the 1930s and 1940s, called Heart of Iron. And it's a time that was described by, to give something to the locals, described by Winston Churchill himself as the Gathering Storm, a period of like upcoming trouble, but also a period of great optimism. And again, to stay with the local, there is maybe not a bigger optimist than Neville Chamberlain, a man who thought that this would be peace in our time in September 1938. How could you be so wrong? But I would say that there was maybe a guy who was even more optimistic at that time, and that man is never that Alan Turing himself. And here is why. Because he made this publication in the 1930s that's saying that if you give someone like a piece of paper with a source code, I cannot tell you if it will it will actually terminate. Which, by the way, this guy's the first programmer, right? First code review ever. It doesn't like give you a thumbs up or anything. Just says, hey, here's a 20-page thesis about how I cannot review this merge request. Setting a really bad precedent here. I'm just saying. So let's debunk this thing. All right. Let's write something. I'm gonna solve the problem for you right now, live on stage in 4 minutes. So will this terminate given a given source? And my answer is yes, it will. Don't believe me? I'll show you. Right, so let's start with the basic thing. Like most programs are made to terminate, okay? Like you just do a thing and you return. If you ever use the Unix console, that's the idea. ls, cd, mkdir, it just does the thing and return, okay? Of course, some smartass in the audience will be like, oh yeah, but do we have interactive programs nowadays, right? Like, you know, your notepad, your video games, your music player. Like they only return when the programmer actually, like the user actually terminates, right? But let's go back to the Greeks, right? Let's go back to basics. We know from Socrates that man is mortal and, you know, he doesn't have time for this shit. So obviously at some point, he will get that pop-up and nobody clicks on the bottom one. Don't lie, I know, you will click this one. Okay, but what if the user is inhumanly patient, okay? Like, this guy is just here to just make me like look like a dumbass on stage. He's like, no, I have wisdom, I have attained enlightenment. My goal in life is to prove Matthew wrong by just pushing and waiting until this program not terminates and just prove me wrong, right? Okay, sure, but bugs, okay? Bugs happen, right? This is like the biggest CVE ever. Like the one I like, the one that C++, for example, or language of choice here, might be running into. So, you know, it doesn't take much, right? Like a 1 byte memory leak is enough for your program to eventually crash because you run out of memory. But, you know, that will happen, like bugs. Okay, this one is kind of convoluted, but bugs, they're a thing, right? Don't tell me you never had bugs. But okay, what if a programmer is a genius, right? Like he has the brain power of like 10 million people, writes a very simple, perfect program that will never crash. Well, sure, he does that, and then he goes to bed, and then the next morning he's greeted by like this nice pop-up, like, hi, which made some, yeah. And this is AI generating like Turing crying in front of his lab. It's a great picture. Okay, right. But what if Turing or whoever he is also remembers to disable Windows Update? You just say, okay, cool. The next thing is power supply, right? Computers need electricity to run, and you know, just not stating anything special. But let's say your electricity provider realizes that there's 2 people on the same name and the same address by mistake, and just decides to shut down both, solve the problem, and you wake up without power. Like that would never happen, right? But what if it does, and then you run out of power? Well, you have a solution too, right? You can buy one of those things, and it will just keep power running, so you can see the experiment going on. And we could continue on with hardware failures because this is obviously the next step in our demonstration. But we have the cloud nowadays, we have virtual machines, so you could just make the thing run on a virtual machine and then copy it in the cloud, make sure that there is always at least one machine with a safe state that can continue to prove that our program will run, right? So this time we solved it, right? It will execute forever, okay? Well, let's go back to Socrates again. Man is mortal, right? So at some point, our observer will die, and people will forget about this program running, and nobody will be there to see that it actually terminates. And if a program does not terminate and there's nobody to see it, does it actually terminate, right? It's a right question. But you know, we can solve that too. We can build a cult that will just be like there to observe this computer. They don't know why because it's been 1,000 years, but they're there to observe that the computer actually terminates or doesn't. And then we create like generation ships or whatever to make sure that even if the Earth blows up, they can still continue to do that in space. That's great stuff. So this time it will execute forever, right? No, because there's this thing called the heat death of the universe, and eventually we're all going to die anyway, and the program with us. So yeah, guess what? Turing was wrong, okay? Like, your program will terminate unless it runs forever without any bugs. It's executed on redundant hardware in an everlasting galaxy. It is observed by a very patient cult that survives through generation and remembers to disable Windows updates. Thank you.